As I'm solving a quadratic and a linear simultaneous equation, my first step is to rearrange the linear equation in terms of one letter. In this case, I'm going to rearrange to have y by itself. So leaving y alone on the left-hand side. Therefore, I'm going to have to move the negative x, in this case across the right. If you move a term over an equal sign, it changes sign. So negative x moves to the right-hand side will now become positive x. Likewise, I need to move the positive 7 across to the right-hand side. Well, the opposite add 7, therefore it's subtract 7. Therefore, I know y is now equal to x minus 7. As I've got two terms, I always place that inside single brackets. Now, substituting into my quadratic, the top equation, here my quadratic equation starts x squared. So I leave x squared alone. Keep the sign, in this case, plus. Here I have y squared. Well, I know y is now x minus 7. Hence, y squared would be in brackets x minus 7 multiplied by x minus 7, because we know y squared means y multiplied by itself. If y is x minus 7, therefore y squared would be x minus 7 multiplied by x minus 7. And on the right-hand side, my quadratic equation is still equal to 25. Leaving the x squared term alone. Now expanding my double brackets, I know that x multiplied by x will give us x squared. I know x multiplied by negative 7 will give us negative 7x. I know negative 7 multiplied by x will give us negative 7x. I know negative 7 multiplied by negative 7 will give us positive 49. Because remember, a negative times negative gives you a positive outcome. And the right-hand side of my equation is still equal to 25. Collecting like terms on the left-hand side. Well, here I have x squared plus x squared. They're like terms as they both end in x squared. If there's no number in front of a term, and the number is 1. So one lot of x squared plus now one lot will give us two lots of x squared. Collecting my single letters of x, here I've got negative 7x, subtract another 7x. Well, negative 7, take away another 7, will simplify to give us negative 14 lots of x. I've still got plus 49. And on the right-hand side, my equation is still equal to 25. I can now see I'm getting a quadratic in terms of the letter x. To solve a quadratic, I always want my quadratic equation to equal to 0. Hence, in this case, I'm going to move the 25 from the right-hand side across the left by doing the opposite. The opposite add 25, therefore subtract 25 from both sides. On the left-hand side, I've still got 2x squared. I've still got a negative 14x. I know that 49 take away 25 will give us 24. And on the right-hand side, I know that 25 subtract 25 will cancel to leave us with 0. As I'm solving a quadratic on a non-calculator paper, and I can see that all three terms are a multiple of 2, i.e. they're all even. Therefore, to make my life easier, I can divide the whole equation by 2, and it does not affect my solution one bit. So on the left-hand side, 2x squared divided by 2 will give us x squared. Negative 14x divided by 2 will give us negative 7x. And 24 divided by 2 will give us 12. And on the right-hand side, my quadratic is still equal to 0. As I'm solving a quadratic, I've got a couple of options available. I could try factorising, or I could use the quadratic formula. I'm going to try factorising. As I have three terms, a quadratic in terms of x squared, therefore it's going to factorise into what we call double brackets. As my quadratic starts x squared, I know each bracket will start with a single x. And don't forget my quadratic is equal to 0 on the right-hand side. I need to find two numbers that multiply together to give us the number term. In this case, our number term is positive 12. And the same two numbers must still add to give us the number in front of the single letter, in this case, negative 7. The only pair that multiply to give us positive 12 and still add to give us negative 7, in this case, can be negative 3 and negative 4. As a negative times negative gives you a positive outcome, negative 3 times negative 4 gives you positive 12, and negative 3 subtract 4 gives you negative 7. As I'm solving, in this case, working out the value for x, I now place each single bracket separately equal to 0. As I want to work out the values for x, looking at my first equation, therefore I must move the negative 3 across to the side. Well, the opposite minus 3, therefore, is to add 3. So one solution is when x is 3. Look at my other equation. As I want to get x by itself, I need to move the negative 4, in this case across to the right. Well, the opposite of minus 4, therefore on the right-hand side, therefore become positive 4. So one solution is x is 3. My other solution is x equals 4. Now I've got my two values for x. I need to substitute back into my rearranged linear equation to find my two corresponding values of y. Well, here I know that y is equal to x minus 7. Substituting for x, in this case when x equals to 3. Therefore y, instead of having x is now 3, will become 3, and I've still got the minus 7. And 3 take away 7 gives you negative 4. Repeating this process now for when x equals to 4. Therefore, y is equal to, instead of having x is now 4, so it's going to be 4. and I've still got subtract 7. And 4 subtract 7 gives us negative 3. So I can see I've got two pairs of solutions. I know when x equals to 3, y is equal to negative 4. And when x equals to positive 4, y is equal to negative 3.
Your turn.